Hello and welcome back to California Geology. I am Dr. Robert Lopez, and I'm going to finish off the Coast Ranges by looking at the Cenozoic volcanic rocks. And remember, when we looked at these rocks, we talked about the Ninox and the pinnacles. But what I want to look at now is look at the trend of ages, especially the volcanic rocks that are on the east side of the San Andreas Fault, because they seem to. Remember, the Pacific Plate is much more active. It's moving at a faster rate, anywhere from about 6 centimeters per year to 4 centimeters per year, depending on the time. Whereas the North American Plate is probably only moving maybe about 1 to 2 centimeters per year, so much slower. So that means that on this east side, there's the separation and the timing is more consistent than it is on the west side, because remember, the San Andreas transform has migrated through time, and so there's been different degrees of offset of the different volcanic units. But again, if we look at the ages of the rock units on the east side of the San Andreas Fault, we find that they go from being older in the south. Ninoc around 23 million years, San Amigdo Hills here 21 million years, the volcanics up near Hollister at Pacheco Pass, Quién volcanics, they're about 10 to 8 million years old. The Berkeley Hills also around 10 to 8 million years old. And then we get to the Sonoma volcanics here, about 13 to and as young as maybe 2.7 million years old. And then Clear Lake. In fact, there's probably still a magma chamber under Clear Lake. There's geysers up there. There's quite a bit of geothermal activity. They're getting power from the geothermal plants up there. So what we do know that's happened is that over time, something has been migrating northward over time. And it probably started right around this region of the Ninoc, or maybe a little bit farther south. But what has been migrating over time? You probably know what it is. One went northward, the other one went south. So what we're seeing the migration of that Mendocino triple junction, right? So it seems like if we go down here, that the Mendocino triple junction has been moving, and where its position was in the past is really documented by volcanism, and it may or may not coincide exactly when the triple junction is at particular position. Maybe the magmatism lags a little farther behind, but nonetheless, it seems to be that as a junction is moving northward, subduction is cut off, because now, so this would be the Pacific Plate here. I'll put PP for Pacific Plate, is in contact with the North American Plate here, right? So in the past here is the North American Plate here. But here is that Farallon Plate, or the Juan de Fuca Plate, and then here is the Pacific Plate, PP over here. So this plate has to be subducted away, and remember, this plate is more or less moving toward the northwest, kind of away from California. So that causes some extension. Maybe you allow some mantle to move up here, maybe some decompression, melting. Although the signature of the individual magmas from these different volcanic fields indicate that at least their chemistry indicates that they're calc-alkaline, which means they're related to subduction zone. So that's one thing that's happening with the volcanic rocks, is we seem to have a younging toward the north, which probably coincides or follows the migration of the triple junction over time. So remember, today the triple junction is off of Cape Mendocino, right? And you can see the volcanism is behind it, right? So maybe that's where we're getting that idea. Another piece of controversy is, not last one, but there's a volcanic field that we'll talk about when we do the Central Valley, and it's really the smallest mountain range in the world, at least that's what I've heard. And those are the Sutter Buttes, and the Sutter Buttes are a series of volcanic rocks that there's some speculation it could be related to the Cascades, but it could be related to the migration of the triple junction as well. And they kind of fall along in this age around 2 million years old, so they're relatively young as well. So we'll look at those in more detail later on. Now, kind of going back to the Monterey Formation and the Cenozoic sedimentary rocks, right? So remember, these Cenozoic sedimentary rocks. They occur on both sides of the San Andreas Fault. And this Monterey Formation is famous because it's the source of California's oil. And remember the diatomite. Well, remember we've talked about diatoms, and diatoms are single-celled organisms. They're part of the kingdom Protista, so it's an algae, and it does photosynthesis. So I usually abbreviate photosynthesis as PSN, right? So they're taking water plus carbon dioxide and making the glucose, right? Plus releasing some oxygen. But in that process, if they need, for photosynthesis, you need the sunlight, right? You need photons from the sun. And so obviously they need to be high in the water column. So they use a couple of varieties of techniques for flotation. One is they're porous, right? In fact, they're extremely porous. They make some of the world's best filters. In fact, you probably heard of diatomaceous earth used for filters. And then they also use some oil and a little bit of oil to help them float in the water column. So one thing about oil, when the plankton dies and it sinks to the sea floor here, right? Let's see, the plankton sinks to the sea floor and starts collecting here. Well, there's going to be a lot of bacteria. And one thing bacteria do is they're known as decomposers. So they're going to take these organic molecules and break them down. And so that means no oil. But remember, during the Miocene time, that's the age of this Monterey Formation. It's Miocene. And anywhere from about 20 to about 10 million years old. During that time, remember, California, the San Andreas Fault was a releasing bend, which means, if you think about the type of bend in the fault, it was bending toward the east, right? So Pacific Plate moving north, North American Plate moving south, right? So here's the north, and this is Southern California down here. And so that means you're going to open up these basins. Remember, I call these pull-apart basins, pull-apart, and they're going to be deep. So one thing, they become very deep, and they become so deep that bacteria can't live there. In fact, we call these anoxic. So an anoxic basin means there's no oxygen, right? No oxygen, which means you're not going to have bacteria. So when the plankton die and sink in these really deep basins down here, they'll collect, and there's no bacteria to break them down, right? So they'll come down here and sink into these deep water basins, no bacteria, so we preserve the oil. So when we talk about the transverse ranges, if you've ever been to Santa Barbara, you've probably looked out in the ocean at the various Channel Islands there, but in the basin, the Channel Island Strait there, you'll see that there's all these oil rigs, and the oil rigs are drilling into the oil deposits there related to this Monterey Formation. So anyhow, let's stop here for now.